In this section, we will create the archer ability for the player character. This will be an end-to-end exercise covering many of the Lyra's framework features. Again, to reiterate, we don't provide any of the assets created during this exercise. The videos cover the steps to download the Epic Marketplace assets and how to modify them for this exercise. During this section, we will download the Paragon Sparrow character from the Epic Marketplace. We will import the Sparrow character mesh in the free Blender 3D software and remove the bow and arrow separately. By the end of this activity, we will have the bow and arrow skeletal meshes and the static meshes to use in Lyra. We will also create the bow and arrow locomotion animations using the Paragon Sparrow animations to use in Lyra. These animations will be loaded into a separate animation layer in Lyra. We will also create a bow release firing animation using the Paragon Sparrow animation. We will use this later as an animation montage. Open the Epic Games launcher. In the Marketplace tab, search for Paragon Sparrow. The Paragon asset has a lot of skins you can choose from. I already have the asset downloaded. Once you download, you will see the Add to Project button. Click the Add to Project button. Select Show All Projects. Select the Lyra course project and click Add to Project. You can see the Sparrow mesh under the Paragon Sparrow folder under Content. Open it. You can see the bow and arrow attached to this mesh. Under Skins folder, you can find different meshes for Sparrow. Open the Zechin Huntress folder and open the mesh. We will use this mesh. Right-click the mesh and under Asset Actions, select Export. Save the FBX file in a folder. Uncheck all the options and export. We will use this FBX file in Blender. Open Blender. And remove the camera, cube and light. In a clean slate, import the FBX file. You can see the Sparrow Huntress 3D model along with the bow and arrow. You can also see the skeletal bones. They are called armature in Blender. Enable both the X-ray mode and the wireframe mode for easy selection as a wireframe mesh. In the object mode, select the Sparrow model. Make sure you see the entire model highlighted in yellow. Now go to Edit mode. Select the body part by part and delete until you have only the bow and arrow. Use the X key and delete vertices after each selection. Keep saving the Blender file. In order to separate the arrow mesh from the bow mesh, use the L key. You can hover the mouse over the arrow mesh vertices and keep clicking L key. Complete this process to fully select only the arrow mesh. Once the arrow mesh is fully selected, press P and do separate by selection. This will separate the arrow mesh from the bow mesh. Now go back to the object mode. You can see two entries now. Rename them to bow and arrow accordingly. Next step is to remove all the bones not related to bow and arrow. The bow bones are present under spine 3, clavicle L, upper arm L, lower arm L, hand L. Bow base and the bones under it are the only bones we need. So remove all other bones in batches. Select root and go to the edit mode. Use armature delete bones to delete all the unwanted bones in batches. Once you complete this process, you will end up with only the bow bones. Next, to export the bow as FBX, select the bow, root and everything except the arrow. Export as FBX. Select the mesh and armature. Check selected objects. Uncheck bake animation and export FBX. Select arrow alone and export as FBX. Choose only the mesh and check selected objects. Export FBX. Rename the bow FBX file as sparrow_bow. Go back to Unreal Engine. Under Content Weapons, create a folder bow. Right click and select Import and choose the bow FBX file. Click Import All. Ignore the warnings. You will see the bow mesh with the skeleton. Remove the default materials created. Open the bow mesh. Choose the Huntress Legs Sparrow material for the bow material slots. Open the bow skeleton and view the bones. Next, for the arrow, we need to set the origin point to the end of the arrow and also the direction of the arrow to x-axis. We will do this in Blender. This is a good exercise again for a lot of use cases where you need to change the origin point for your meshes. In Blender, remove the camera, cube and light. Import the arrow FBX. You can see the origin of the arrow in the middle. Using Shift and right click, move the 3D cursor to the end of the arrow. Now select Object, set Origin to 3D cursor. You can see the origin at the end of the arrow now. Expand the transform section, set all 0 for location and rotation. Apply all transforms. Set y to -90. Now the arrow will be pointed in the x direction. Apply all transforms. Export as FBX. In Unreal Engine, import the Arrow FBX file. Select Skeletal Mesh, clear the skeleton, import all. Ignore warnings. You can see the arrow mesh with skeleton. Open the arrow mesh and choose the sparrow Zechin legs in the material slots. Remove the extra materials generated. Using the Make Static Mesh option, you can also create the static mesh for the bow and arrow. Now, we will create the animations for the bow. Create the folder animations. Go to Sparrow Animations. Open RMB loop. The bow is stretched and in idle position. Rename it to Bow Idle. Move it to Weapons Bow Animations folder. Open RMB Fire. You can see the bow is released and then stretched back for the fire. Duplicate and rename it as Bow Fire. Move it to Weapons Bow Animations folder. These are the two animations for the bow. Even if you can't follow this exercise and want to get the bow and arrow from elsewhere, you need these two animations for the bow asset you have. Go to the Bow Animations folder, select the Bow Fire, right click and choose Replace Skeleton. Choose Sparrow underscore bow underscore skeleton. Open it to see the animation in action. Repeat the same steps for the bow idle. This completes the exercise and we are ready for the creation of archer animations in the next lecture. Thank you for watching this lecture. See you in the next one. In this lecture, we will add a new animation layer for Archer in Lyra. Lyra has inbuilt animation layers for unarmed pistol and rifle weapons. We will add a new animation layer for the Archer. In a previous lecture, we downloaded a Paragon Archer asset Sparrow from the Epic Marketplace to get the bow and arrow. We will use the same Sparrow asset to retarget the Archer animations and build the animation layer in Lyra. Go to the content, Paragon Sparrow, Characters, Heroes, Sparrow Animations folder. All the movement, action and aim offset animations are in this folder. For the aim offsets, we will retarget the full body animation poses and build an aim offset. For the Archer movement animations, we will use the animations from the unarmed animation layer for the lower body, and for the upper body, we will choose an idle pose from Sparrow and merge both the animations to create a new animation. We will use the record feature in the animation blueprint for the same. This lecture is more of a guideline for you to get an idea about how to create your own animations for the Archer. So, we won't go step by step in creating everything. Instead, we will do some of the animations as an example for you to try this exercise yourself. This exercise is lots of fun and there is no limit to your creativity with the free assets available in the marketplace. Whatever I am showing here is just one way of doing this. You can explore a lot more ways to achieve the same. But this is going to be a good start for you. Go to the folder Content, Characters, Heroes, Mannequin, Animations. Under Locomotion, you can see folders for Pistol, Rifle, Shotgun and Unarmed. Open the Unarmed folder. You will see all the unarmed animations in the folder. The ABP Unarmed Anim layers is the animation blueprint layer for the unarmed animations. We will go through this in a moment. Let us first create the aim offsets for the Archer first. In the animations folder, open the subfolder aim offsets. You will see 6 aim offsets there. Let us explore the aim offset for pistol. Open the AOMM pistol idle ADS. This is the main aim offset asset. All the aim offset animations are added to this. If you hover over the different positions in the aim offset, you will see the animation pose assigned to it. Just hold the control button and move over the graph to see the aim offset in action. In the Asset Details panel, you can see all the animations assigned to this aim offset and you can change this accordingly. To get these animations for the Archer, we need to retarget the animations from Sparrow to Lyra's Manny. Before that, let's review the Sparrow's aim offset. Go to the folder Paragon Sparrow, Characters, Heroes, Sparrow, Animations, Aim Offset. Open the AO_idle aim offset asset. You can review the animations assigned to the aim offset. These are the list of animations in an aim offset. So all these animations should be retargeted and added to the new aim offset asset. You can pause the video and review the animations. Go to the folder Mannequin Animations Locomotion. Create a new folder Bow and another folder AO inside that. Now from the folder Mannequin Animations Aim Offsets, duplicate the AO MM Pistol Idle ADS and move it to Locomotion Bow AO folder. Rename it to AO MM Bow. Next, we need to retarget the AO animations and then assign them to AO MM Bow. I will retarget 2 animations and you can try and do it for all other animations. Go to the Paragon Sparrow folder and the Animations Aim Offset folder within it. Open the animation Idle AO CD. You can see under the additive settings Idle AO CC animation as the base pose animation. This animation is referenced by all other aim offset animations. So we need to retarget this first and then the other animations. We also need to reference this Idle AOCC retargeted animation to the other retargeted animations again. Let's do it now. Right-click Idle AOCC, select Retarget Animation Assets, duplicate and retarget animation assets. In the window, choose IK Retargeter as RTG UE4 Mani to UE5 Mani. Source skeletal mesh as Sparrow and the target skeletal mesh will be SKM Mani. Change the folder to the newly created AO folder under Mannequin Animations Locomotion Bow. Click on Retarget. Rename the retargeted animation as Bow Idle AOCC. This is the base aim offset pose animation. When you open this animation, the same animation should be referred to the base pose animation. Next, follow the same steps to retarget Idle AOCD. Once retargeted the animation, it will be wrong. That is due to the wrong reference in the base pose animation. You will also find an additional retargeted CCAO animation. This is due to a referenced animation. Please delete it. Rename the retargeted animation to Bow Idle AOCD. Choose Bow Idle AOCC as the base pose animation. Now it should look good. Continue to do the same for all the AO animations. Continue to do the same for all the AO animations. Once all the animations are retargeted and base pose animation set, let us now build the aim offset. Open the AO Bow aim offset created earlier. It was duplicated from Pistol's aim offset. Replace the aim offset animations of Pistol with the newly created aim offsets of Archer. As a last step, we need to set the preview base pose to an idle pose. We need to retarget an idle animation pose from Sparrow for this. You can follow the same steps for retargeting the idle animation from the Sparrow animations folder and rename it to Bow Idle Ready. Set the preview base pose as Bow Idle Ready. Place this animation in the Animations Locomotion Bow folder. Now you can test the aim offset. Next, we will create the bow animations. Go to the Locomotion Unarmed and duplicate the ABP Unarmed Anim layers. Move it to locomotion bow. Rename it to ABP bow anim layers. Open it. You will see the unarmed animations there. You need to create an equivalent bow animation for all these and set it. I am ignoring the crouch portion in this. Try to cover as much as you can and the blending of the animations will be very good. Let us take the first animation, unarmed walk forward. Open it. You can see the forward movement by the mannequin but standing in the same location. In the root motion section, uncheck the enable root motion and force root lock. You can see the mannequin moving forward now. Save the animation. This step is needed before creating the new animation, but please ensure you revert this back in each of the unarmed animations, as they are used in Lyra already for the unarmed locomotion. This walk forward animation is for the lower body. For the upper body, we will create a single frame animation. For this, we will use the center aim offset single frame animation which we created earlier. Go to the bow AO folder, duplicate the M bow idle AOCC and move it to the bow folder. Rename it to bow idle pose. Also change the additive setting to no additive. Now let's create an animation blueprint for the purpose of creating new animations. Go to the locomotion folder, right click and create animation blueprint. Choose the skeleton as sk_mannequin. Name the animation blueprint as ABP animation creator. Open the animation blueprint. Add a layered blend per bone node. In the details section, select blend mask for the blend mode. Under blend masks, add upper body lower body split mask. Also select mesh space rotation blend. Connect the layer blend per bone node to the output pose. From the asset browser, drag and drop unarmed walk forward and add it to the base pose of the layered blend per bone node. Drag and drop bow idle pose and connect it to the blend poses 0 node. Now compile and you will see one loop of the animation with the blended bow pose and the walk forward animation. Just ensure the character moves forward from the current location. Now let us record this animation sequence. Click the record button. Choose the animation name as bow walk forward. And choose the folder as content characters heroes mannequin animations locomotion bow. Then click on compile. The animation sequence will happen. Wait for some time after the animation loop is completed and stop the recording. Now open the new animation bow walk forward. Pause the animation and just move the timeline and see when the animation is starting and when it ends. You need to trim the space before and after the animation. For this, you can go to the right keyframe and then right click and select remove from to trim the animation. Keep the enable root motion true and force root lock true and do this trimming. Save the final animation. Repeat the same for all other animations. Open ABP bow anim layers. In the details section, you can change the unarmed walk forward animation to the bow walk forward animation we created earlier. Do the same for all other animations and your bow animation layer will be ready. Thank you for watching this lecture. See you in the next one. In this and upcoming lectures, we will work on the Archer gameplay ability for the character. When you load the shooter gym level, currently the metahuman encounters a melee bot chimera. Let us change this back to the shooter bot and also make him idle. Go to the shooter core content. Experiences folder. Open the shooter game elimination experience. Under add components, change the melee bot spawner to shooter bot spawner. Go to editor preferences. Under Lyra developer settings, uncheck the allow players bots to attack. Go to the root folder, search for random, find and open the pick random character blueprint. Select Manny instead of Chimera as the shooter bot. Compile and save. Run the shooter gym level and you can see the idle bot. The characters are spawned without a weapon, so they don't have the weapon in hand. Go to shooter core content, weapons. Create a new folder, bow. Create a new blueprint class. select parent as actor class. Name the blueprint as B_bow. Open the blueprint, add a skeletal mesh component and name it bow. Select bow and choose the skeletal mesh asset as sparrow bow. Now we will add the arrow for the bow. Add a skeletal mesh and name it arrow under the bow as a child component. Select arrow and choose the skeletal mesh asset as arrow. Also choose the parent socket as bowstring mid, which will attach the arrow to the middle of the bowstring. Choose rotation and then rotate the arrow to the right position. Compile and save. Go to the main content, weapons, bow and animations folder. Create a new animation blueprint. Choose the skeleton as sparrow bow skeleton. Name it ABP_bow. Open the animation blueprint. Drag the bow idle animation asset and place in the anim graph. Add a default slot node. This is used to run the animation montage dynamically later for the bow fire. Connect the nodes. Open the B_bow blueprint. Choose the ABP bow animation blueprint in the anim class section. You can see that the bow stretched idle position is default now in the bow blueprint. Adjust the arrow position. Remove the angle snap for a finer adjustment. Go to the bow animations folder. Create an animation montage for the bow fire by right-clicking on it and selecting Create Anim Montage. Name it AM bow fire. Go to the pistol animations folder. drag and copy the AM pistol fire animation montage for the mannequin to the bow animation folder. Rename it to AM bow fire. Open it. Change the slot name to default group.upperbody as we want this animation montage to fire only to the upper body even during the character movement. Change the pistol fire to bow fire fast. Now you can notice an anim notify section called AN play weapon montage. This section fires the child mesh animation montage. When the character is holding a bow, during the bow fire animation for the mannequin, the bow also fires its animation montage where the stretched bow gets released. Select the anim notify and change the montage to play to AM bow fire. Save all. Thank you for watching this lecture. See you in the next one. Let us create the Lyra equipment definition, Lyra ranged weapon instance, and the Lyra inventory item definition for the bow. Search for WID_pistol. The Lyra equipment definition for the pistol. Use the Show in Folder view to go to the Assets folder. Shooter core content, weapons, pistol folder. Copy WID_pistol to the bow folder. Rename it to WID_bow. Under equipment, the Lyra ranged weapon instance is available, which is B_weapon instance_pistol. Navigate to the folder. Make a copy of it for bow. Rename it to weapon instance_bow. Open the WID_bow and replace the instance type to weapon instance_bow. Replace actor to spawn with B_bow. Choose the attach socket to weapon_L. The weapon blueprint selected here will be spawned in the player character's hand at the specific skeleton socket weapon_L. In the attached transform, change the rotation Z value to -15. This is an approximate value for the position of the bow. You can adjust this based on your needs. We will have a separate video on this, how to adjust the weapon position dynamically. Now let us make a copy of the ability set for bow. Go to the folder for weapon pistol. Make a copy of the ability set for shooter pistol to the bow folder. Rename it ability set_bow. Go back to the WID_bow and replace ability set_pistol with ability set_bow. Open the ability set_bow and remove all the gameplay abilities listed. Go to the weapons pistol folder. Make a copy of the ID underscore pistol to the bow folder. Rename it to ID underscore bow. Open ID underscore bow. Change the display name to bow. Equipment definition to WID underscore bow. Display name when equipped to bow. Skeletal mesh to sparrow underscore bow. Display name to bow. We won't make changes to other fields for now and leave the same. Compile and save. Go to the B underscore weapon instance underscore bow and change the equipped anim set animation blueprint layer to ABP underscore bow anim layers, both for the default layer and the layer rules. The purpose of the layer rules is to add a cosmetic tag for the mannequin, and based on the tag, the animation layer can be changed. For example, Manny will be default and Quinn can have an animation style feminine cosmetic tag added. This allows to add a separate animation layer for Quinn. In our case, we will use only the default animation layer for the metahuman character. We will not make changes to other sections. Save the blueprint. Now go to the hero shooter mannequin under shooter core game. Under variables, choose WID underscore bow for the weapon ID. For initial inventory items, add an item and choose ID underscore bow. Open the shooter gym level. You can see the metahuman character holding the bow. Next, we will implement the arrow blueprint, which will be spawned from the bow on each bow fire and move towards the target object and hit it to cause a damage. We will create an arrow blueprint and the gameplay ability for bow fire. Thank you for watching this lecture. See you in the next one. Go to the shooter core weapons bow folder. Create a new blueprint class with parent as actor. Name it B arrow. Open the blueprint. Add a static mesh component. Name it arrow. Select the static mesh SM underscore arrow. Move the arrow component as root component. Add a projectile movement component. The projectile movement component is used to provide the movement to the arrow. Set the initial speed to 2500 and the max speed to 50,000. Next, we will implement the functionality to apply damage to the character hit by the arrow and also produce the damage number pop-up on top of the hit character. For that, we will use a gameplay effect. Create a variable gameplay effect context of type gameplay effect context handle. Create a helper function, make gameplay effect context. This function will be later used in the main event graph. Add an input hit result of type hit result. Add the player character node to get the player character reference. Add the get ability system component node for the player character. Make the effect context out of that. Now set the gameplay effect context variable using the make effect context. Add the hit result data to the gameplay effect context. Add the hit result data to the gameplay effect context from the input parameter hit result. Check the reset boolean flag. This hit result is used by the gameplay queue to get the location for displaying the damage pop-up numbers. Open the event graph. Add the event hit. This event will be triggered when the arrow hits an actor. Add a switch has authority node. This is more of a helper function used in Lyra for multiplayer network feature for authorization. We will cover this later in a multiplayer course. For now, consider this as a positive flow with authority in a single player game. Call the helper method make gameplay effect context. Add the hit result from the event hit input. Get player character and from there get the ability system component. Use the apply gameplay effect to target node and set the first target to the ability system component of the player character. Break the hit result from the event hit input and use the hit actor to get the ability system component. Apply the same to the second target of the apply gameplay effect to target node. Set the context to the gameplay effect context variable. We will now create a new gameplay effect for the arrow. Search for GE damage pistol. Copy it to the shooter core content weapons bow folder. Rename it to GE underscore damage underscore arrow. Open the same. Go to the gameplay effect executions, calculation modifiers, modifier, magnitude section. The scalable float magnitude section determines the damage caused by the gameplay effect. For the pistol, the value set is 18. We can change this to 10. Now for every hit of the arrow, 10 health points will be reduced for the character hit by the arrow. Compile and save. Open the arrow blueprint again. In the node, apply gameplay effect to target. Set GE underscore damage underscore arrow as the gameplay effect class. Add a delay node with duration set to 1. Add a destroy actor node. This will destroy the arrow after 1 second hitting the target. Compile and save. Thank you for watching this lecture. See you in the next one. Now, let's create the gameplay ability for Bowfire. Lyra has an inbuilt C++ class for the ranged weapons. In the weapons bow folder, let us create a new blueprint class derived from the parent Lyra gameplay ability ranged weapon. Name it GA underscore bow. Open the blueprint. Let us add a few variables. Add location of type vector, which holds the position where the arrow starts. Direction of type rotator, which holds the direction in which the arrow travels. Hit target of type vector is the arrow hit location. Origin offset of type float is a small gap between the original origin and the actual origin of the arrow to avoid any collisions or damage to the player character. Create a new function set location and direction. This helper function sets the location and direction for the arrow. Use the get Lyra character from actor info node to get the Lyra character. Get the mesh for the character. And from the mesh, get the socket location for the socket named weapon underscore L. It's the same socket where we attach the bow to the left hand. From the character, use the get actor forward vector and multiply it with the original offset. Set the original offset value to 100. This value can be changed to your requirement. Add the output to the socket location. This will provide the location for the arrow actual origin. Set this value to the location variable. Use the find look at rotation node with start as location and the target as hit target, which is the arrow hit location. Find look at rotation gives the directional value of the arrow between the start and target. Set the output to the direction variable. Add a return node to finish the function. Go to the main event graph. Add the event active ability node. This node is fired when the gameplay ability is activated. Add the sequence node. The sequence node executes the flow in each sequence one after the other. In the first sequence, add a is locally controlled node which checks if the character is controlled by a local controller and not network. If so, call the start ranged weapon targeting node. This is an inbuilt function from the parent class to track the target through the reticle. In the sequence 2, call the play montage and wait node. For the montage to play, select the am_mm_bow_fire animation. This is the animation montage for the mannequin during the bow fire. Uncheck the stop when ability ends boolean flag. Add an end ability node. This is called when the montage on completed or on interrupted or on cancelled is fired. Now call the set location and direction helper function created a bit earlier. Add a has authority node for network authorization. Considering the single player for now, the node returns true. Now call the spawn actor node to spawn the arrow. Split the spawn transform to set the location and direction for the arrow spawned. Choose b_arrow for the spawn actor class. Use the get Lyra character from actor info to get the Lyra character and add it to the instigator. Instigator is the character who fired the arrow and holding the bow. Set always spawn and ignore collisions for the collision handling override. Next, we will execute a gameplay cue which will produce a sound effect during bow fire. Add a execute gameplay cue with params on owner mode. Add a make gameplay cue parameters node and attach the output to the gameplay cue parameters. Now, create a new gameplay cue tag, gameplay cue.weapon.bow.fire. For this, click on the plus to add a new subtag under gameplay cue weapon and add bow.fire.click. Add new tag. This gameplay tag identifies the gameplay cue. Next, we will create a new gameplay queue for Bowfire and attach the newly created tag once we complete this blueprint. Add an event on ranged weapon target data ready node. This event gets the hit result at the reticle position. Use the get hit result from target data function and break the hit result. Set the hit target variable using the location value. Search for GCN underscore weapon underscore pistol underscore fire. Go to its folder. Copy it to the bow folder. Rename it to GCN underscore weapon underscore bow underscore fire. Open it. OnBurst is an inbuilt function for the parent class GCN burst. The gameplay queue execution happens in this function. To make it simple for the Bowfire sound effect, we will remove the fire impact effect section and all the underlying nodes. Reconnect the Lyra get weapon node with the set weapon sound params node. This will remove the other VFX effects for the gunfire and keep only the sound part. For now, let us not get into the details of this gameplay queue and we will just use this. In the class defaults details section, under gameplay queue tag, edit the gameplay queue.weapon.pistol.fire and replace it with the newly created gameplay tag gameplay queue.weapon.bow.fire. Compile and save. Next, we will update the ability set underscore bow. Open the ability set bow. Add an entry in the granted gameplay abilities. Add the ability GA underscore bow. Add the input tag.weapon.fire. It's the same input tag used for gun abilities. Go to the shooter gym level. You can see that the metahuman character is equipped with the bow and able to fire. You can also see the damage number pop-ups appearing from the hit location. Next, we will create the weapon spawner and the weapon pickup definition for the bow. So the character can go and pick up the bow weapon from the environment. Select the rifle weapon spawner and using the Alt key, make a copy of it. Go to the Lyra weapon pickup section. Change the light color to your likeness. We need to create a weapon definition. Go to the folder for rifles weapon definition. Make a copy of it to the bow folder. Rename it to weapon pickup data underscore bow. Change the display mesh to sm underscore sparrow underscore bow. Change the inventory item definition to ID underscore bow. Now, go select the weapon spawner for the bow in the shooter gym level. Change the weapon definition to the newly created weapon pickup data underscore bow. You can see the bow displayed in the weapon spawner. Go to the hero mannequin blueprint. Change the default weapon ID to WID underscore rifle and the initial inventory items to ID underscore rifle. Now the metahuman will be equipped with rifle by default when spawned. Compile and save. Run the shooter gym level. Go and pick up the bow and start firing arrows. This concludes the bow and arrow ability section. Thank you for watching this lecture. See you in the next one. In this lecture, we will develop the melee sword and shield ability for the character. This is a simple melee ability to showcase how you can use Lyra, and you can extend on this for various use cases. We will use two free Epic Marketplace assets, Paragon Melee Character Greystone and Fantasy Weapon Sample Pack to build this ability. Open the Epic Launcher. Search for Paragon Greystone. Open it. Select Add to Project after downloaded the asset. Show all projects. Select the course project. Select the nearest compatible version. In my case, 5.1. Add to project. Paragon Greystone has a lot of skins which you can use in your projects. In this lecture, we will use only the melee animation from this asset. Search for weapons. Select the tag free under max price. Select the free fantasy weapon sample pack. Add to project. Show all projects. Select the course project. Select the nearest compatible version. In my case, 5.0. Add to project. You can see the Paragon Greystone folder with the animations. And weapons underscore pack folder with the skeletal and skeletal meshes for the weapons. Go to the shooter core content weapons folder. Create a new folder sword. Open the sword folder. Create a blueprint class with parent as actor. Name it B sword. Add a skeletal mesh component. Name it sword. Make the sword skeletal mesh as the root. Select SK sword as the skeletal mesh. Compile and save. In the weapons folder, create a new folder shield. Open the shield folder. Create a blueprint class with parent as actor. Name it B_shield. Add a skeletal mesh component. Name it shield. Make the shield skeletal mesh as the root. Select sk_shield as the skeletal mesh. Compile and save. Next, we will retarget an animation from Greystone asset to create a melee animation montage. Under Greystone animations, select the attack primary A animation. Right click, retarget animation assets, duplicate and retarget animation assets. Choose IK retargeter as RTG UE4 Mani to UE5 Mani, source skeletal mesh as Greystone. Change the folder to shooter core content, weapons, sword. Click retarget. Open the retargeted animation and verify. Duplicate attack primary A and rename it to attack primary A additive. Open the animation. Under additive settings, select local space, base pose type as frame from this animation. Select the root folder. Search for am_mm_pistol_melee. Show in folder view to go to the specific folder. Duplicate the animation montage. Rename it to am_mm_sword_melee. Move it to the sword folder. Open the AM/MM sword melee. Select the MM pistol melee. And replace it with attack primary A. Replace MM pistol melee additive with attack primary A additive. Check the animation montage. Select the root folder. Search for GA melee chimera. Go to the specific folder. Duplicate and rename it to GA melee sword. Move it to the sword folder. Open GA melee sword. Set the animation montage to AM, MM, Sword, Melee. Select the root folder. Search for ability set underscore shooter pistol. Go to the specific folder, duplicate and rename to ability set sword. Open it. Change the ability GA weapon fire pistol to GA melee sword. Remove the reload and auto reload gameplay abilities for the pistol. Keep the input tag as input tag weapon fire. Select the root folder. Search for B weapon instance pistol. Go to the specific folder, duplicate and rename to weapon instance underscore sword. Move it to the sword folder. Open the weapon instance sword. And change the equipped anim set to ABP unarmed anim layers. You can leave the other settings unchanged. Compile and save. Select the root folder and search for WID pistol. Go to the specific folder. Duplicate and rename it to WID sword shield. Move it to sword folder. Open it. Change the instance type to weapon instance sword. Choose ability set underscore sword. Clear the actors to spawn. Add 2 new items. For the first item, select B underscore sword for the actor to spawn. Attach socket to weapon underscore R, which is the right hand socket. For the attach transform, I have calculated values approximately. They can be changed for your needs. Or copy the values I enter here. For the second item, select B underscore shield and attach socket as weapon underscore L, which is the left hand socket. Change the attach transform values as per your need or copy the values I enter. Compile and save. Go to the root folder, search for id_pistol. Go to the specific folder, duplicate and rename to id sword shield. Move it to the sword folder. Change the display name to sword. Change the equipment definition to WID sword shield. Display name when equipped to sword. Change the skeletal mesh to SK_sword. Compile and save. Open the shooter gym level. Using the Alt key, make a copy of the weapon spawner for bow. We need to create a new weapon pickup data for this sword now. Go to the folder, duplicate the weapon pickup data for bow and rename to weapon pickup data_sword_shield. Move it to sword folder, open it. Change the display mesh to SM_sword. Change the inventory item definition to ID_sword_shield. In the weapon spawner, change the weapon definition to weapon pickup data sword shield. Run the level. You can see the melee action from the character. Just as an added info, I have changed the character mesh for the shooter and also changed the Lyra developer settings to keep the shooter idle for testing purpose. Thank you for watching this lecture. See you in the next one.